Astronomers may have just found evidence of a new world hiding in the outer reaches of our solar system, and surprisingly, it's not the long-theorized Planet 9. A recent study from Princeton University has proposed the existence of what researchers are now calling Planet Y, a smaller and closer planet that could be subtly bending the orbits of distant Kuiper Belt objects. If proven true, it would mark the first addition to our planetary family since Neptune was discovered in 1846, a discovery that could reshape our entire understanding of the solar system. In this video, we'll dive deep into what Planet Y is, why scientists think it might exist, and what comes next in the search for this mysterious world. The idea of hidden planets lurking beyond Neptune isn't new. For over a century, astronomers have speculated that unseen gravitational forces might explain the strange movements of icy bodies far beyond Pluto. When Pluto was discovered in 1930, many thought the mystery was solved, but as telescopes improved, scientists realized Pluto was far too small to cause the orbital irregularities they observed. Those anomalies remained unexplained, until now. In August 2025, Princeton astrophysicists Amir Siraj, Christopher Chiba, and Scott Tremaine published a groundbreaking study in the monthly notices of the Royal Astronomical Society, proposing the existence of Planet Y, a hypothetical world orbiting somewhere between 100 and 200 astronomical units, AU, from the Sun. To put that in perspective, 1 AU is the distance from Earth to the Sun, so this planet would be roughly 100 to 200 times farther away than we are, nestled deep in the solar system's frozen frontier. The team analyzed the orbits of more than 150 Kuiper Belt objects, or KBOs, icy remnants left over from the early solar system. After accounting for the gravitational pull of Neptune, they found something peculiar. The orbital planes of many objects between 80 and 200 Australian dollars were systematically tilted, forming a subtle but consistent warp. This tilt wasn't random, and statistically, it was too precise to ignore. It hinted at the influence of a massive, unseen body, something tugging ever so slightly on these distant objects, bending their paths over time. The scientists modeled several scenarios to explain the anomaly. Could it be the collective gravity of the Kuiper Belt itself? The tidal pull of the Milky Way? Perhaps a passing star that brushed close to our solar system long ago? Yet none of these scenarios could reproduce the pattern as effectively as a single orbiting planet. Their models suggest Planet Y could have a mass between 25 and 450 times that of Pluto, which would make it somewhere between Mercury and Mars in size. It would orbit at an angle, roughly 10 to 15 degrees inclined relative to the main plane of the solar system, and would be smaller and closer than the much-hyped Planet 9, which is theorized to be 5 to 10 Earth masses at a much farther distance of around 600 Australian dollars. So far, no telescope has seen Planet Y directly. The evidence is purely gravitational, a mathematical fingerprint written into the Kuiper Belt's architecture. Yet that fingerprint is so precise, so consistent, that many astronomers now view the Planet Y hypothesis as more than just speculation. It's a scientifically testable prediction, one that could soon be confirmed or disproven with the next generation of telescopes. If Planet Y truly exists, it would challenge everything we thought we knew about our solar system. For decades, we've believed the planetary family ended with Neptune, followed only by a debris field of icy remnants. But Planet Y's existence would suggest that the early solar system was far more dynamic, producing more large planets than we ever realized, some of which may have survived on distant orbits for billions of years. There are three main theories about its origin. 1. That it's a native survivor, a planet formed near Jupiter or Saturn and later flung outward during the chaotic early days of the solar system. 2. That it's a captured object, an interstellar wanderer that drifted close enough to be caught by the Sun's gravity. And 3. That it's a companion to Planet 9, a smaller sibling working together to shape the outer solar system's strange architecture. Each scenario would add an entirely new layer to how scientists understand planetary formation and migration. The predicted mass of Planet Y also matters. If it's truly tens or hundreds of times heavier than Pluto, it would have enough gravity to clear its orbit, meeting the official criteria for full planet status under the International Astronomical Union's 2006 definition, the same definition that reclassified Pluto as a dwarf planet. At roughly 50 times Pluto's mass, Planet Y would easily qualify as a real planet, not a dwarf one. Its discovery would also help solve one of the biggest puzzles of the Kuiper Belt: why certain groups of objects share similar angles and inclinations, as if being gently guided by an unseen hand. Planet Y could be that hand, a missing gravitational piece that ties the puzzle together. Of course, not everyone is convinced. Some astronomers argue that the warp could simply emerge from the combined gravitational pull of many smaller bodies rather than a single large one. Others believe the apparent pattern might be exaggerated due to observational bias. We simply haven't mapped enough of the outer solar system to be sure. Still, the Princeton team's model reproduces the observed data with remarkable accuracy and fewer assumptions than competing ideas. That's why the hypothesis continues to gain traction among astrophysicists. If confirmed, Planet Y would serve as a missing link between the inner planets and the farthest regions of the solar system, showing that planetary formation continues smoothly outward rather than stopping abruptly after Neptune. The next phase of this mystery will hinge on observation, and one telescope in particular may hold the key. The Vera C. Rubin Observatory in Chile, set to begin full operations soon, is tailor-made for this kind of search. Its Legacy Survey of Space and Time, LSST, will photograph the entire southern sky every few nights, detecting faint, slow-moving objects at the solar system's edge. Planet Y, at $100 to $200 would be extraordinarily dim, possibly 1,000,000 times fainter than the faintest star visible to the naked eye, and moving just a few arcseconds per year. Yet LSST's repeated scans and sophisticated data analysis could detect its subtle motion across the stars. If the planet exists, Rubin's telescope may spot it directly or at least reveal its presence through how other objects move. The implications of such a discovery would be monumental. It would be the first new planet discovered in nearly 2 centuries, a historic leap in astronomy. It could explain why some long-period comets enter the inner solar system from unusual directions and help us understand how planets form and evolve in other star systems. Finding Planet Y would also reignite the debate about what defines a planet. Pluto's demotion to dwarf planet status in 2006 left many people dissatisfied, but a Mars-sized planet at $100 would have no such ambiguity. It would be a true planet, restoring a sense of symmetry and completeness to the solar system's design. Even if the LSST finds nothing, the search won't be in vain. Every image, every data point collected will refine our understanding of the Kuiper Belt structure. We might learn that its strange warp results from distributed mass effects or ancient stellar encounters instead of a hidden planet. The process itself will uncover thousands of new minor worlds, expanding our map of the solar system's outer boundary. Already, Planet Y has sparked discussions about future deep space missions, robotic probes that could one day venture beyond Neptune to explore this mysterious region firsthand. Whether Planet Y exists or not, its search captures the true spirit of science. Discovery isn't about certainty, it's about curiosity, about chasing the unknown and letting the evidence guide us. Each unanswered question leads to new knowledge, and sometimes, the pursuit itself is as valuable as the result. Planet Y remains a mystery for now, but one thing is clear: even after centuries of exploration, our solar system still holds secrets waiting to be found.